Hey everyone, Mr. Sackler here. So this is not your average video. This video is more of a problem-solving, real-world, really hard to understand time-space video on something called the Fermi Paradox. So if you're curious as to why this video is being made, the answer is wait, but why? A fantastic channel that I've been following for a long time has definitely inspired me as a teacher because one of the most important things that I think that any person, especially a student, should ask is wait, but why? Why does it work? And that is part of why I went into education. Why does something work? And that is my goal to try and explain to you guys today the Fermi Paradox. So let's get started. So this paradox starts looking at the night sky over here, thinking about what you felt the last time that you looked at the night sky. And I want you to think back to the last time you looked up at the stars at a time in your life where you actually saw them. Not like New York City where you look up and you don't see the stars, but really see those stars. Maybe it was one night in the summer or one night in the winter when it was cold and you were looking up at the sky and you really just, you looked up and you thought, what is out there? And that feeling of being struck by this beauty is something that a lot of people have felt. And a lot of times the question is, where is everyone when we feel that? Like, are we really alone in this universe? Because the stars in the sky, it seems vast. There are so many stars in the sky, and at most we can see 2,500 stars. And those 2,500 stars are 1/100th millionth of all the stars in the galaxy. Not even an amount that you can imagine. It's too large. There's too many things in the sky. So really, if you want to visualize this, this tiny little circle right here is all our entire galaxy, our night sky is worth in the whole Milky Way, which is one galaxy of many. That tiny little circle. We are a speck, but that doesn't make us less significant because we're something very special because we have had life occur on our planet. And the question is there intelligent life somewhere else? So I can't answer this question, but what I can tell you guys is that in terms of all galaxies out there, the quoted range of planets and stars on any different galaxy is somewhere between 10 to the 22nd and 10 to the 24th. If you were to then take this and try and represent this as a number, it is insanely big. There are so many different planets and stars out there. But what's really important for you to think about is not to think of literally how many stars there are, but the fact that there is just basically an uncountable number of possible planets and stars out there. And with that idea, that has to say that with all of the possible planets in the universe, there have to be at least some like Earth. So where is the life? Like with so many possible planets and stars out there, there's got to be Earth-like planets. In fact, there are 100 billion billion. So think of a billion with all the zeros that it happens to have, and there's 100 of those. And with that number of planets in all of this night sky, of them, we've predicted with general certainty there's at least 100 Earth-like planets for every grain of sand in the world. There's a lot of sand in the world, guys, like a lot of sand. So there are a ton of Earth-like planets in these 100 billion billion Earth-like planets, which is a huge number. And if you want to know how much 100 billion billion looks like, multiply 100 billion times 100 billion. It's a huge number. So moving forward, we're going to have to kind of like figure out how do we figure out how many possible intelligent civilizations there are in the universe. In order to try and think about that, we are going to have to start thinking about something in terms of the global scale of the world. So at one point, the Big Bang happened, in which that started our universe. That Big Bang then was a really long time ago. 8 billion years ago, the next observable planet that we're able to discern was born. We'll call it Planet X. So 8 billion years ago. Think of all the problems that have arisen in the last 10 years. This is not 10 years, 100 years, 1,000 years, 10,000, a million. It is billions of years ago, something you cannot even process. And then 3.48 5-ish billion years later, Earth is born. So billions of years different. And then here we are at present day. So if, let's imagine planet X over here has some sort of similar story to Earth, let's take a look at what's going on. So there's a 3.46 billion years difference between where that planet started and where we are currently. So in terms of just the scale, T-Rexes were born closer to the time that planet X was born than our own planet was born. So they are so far apart, it is almost incomprehensible. So the entire lifespan of our planet Earth is 4.54 billion years, which is a really long amount. And what we're trying to think about right now is something that's called civilization types. Because in terms of the global scale of this galaxy and this planet and the other planets, we want to think about what are the different type of possible civilizations that have arose. So the first one that we're going to talk about is something called the Type 1 civilization. And a Type 1 civilization has the ability to use all energy on their planet. And that is something that we are headed towards. We are able to use solar energy, we have gasoline energy, we have chemical, nuclear, so many different types of energy we're currently using on our planet, but we have not used all of our planet. We've not quite a Type 1 civilization, but we're really close. So we're close to the first type of global civilization, which we could generalize as a Type 1 civilization. The second type, a Type 2 civilization, is someone who can harness all of the energy in their host star. So that's like draining the sun and using all of the energy. So we already use solar energy, but we're not using solar energy to the most capacity that it can. We're just using it in a very renewable, efficient way. But if we were able to drain the star of all energy it had, we can't imagine how that would happen, but that would be what a Type 2 civilization is able to do, to harness that amount of energy, to use that energy. Then, lastly, a Type 3 civilization is something I can't and you cannot even imagine, because they are going to access power comparable to the entire Milky Way galaxy. By the way, the Milky Way galaxy looks like this if we scroll back up. So this is our little speck over here. So we'd be able to harness, think of in this little speck is where our sun is. So we don't even know how to harness the power of our sun, let alone all the millions and billions of suns out there that we'd be able to harness the power of in this space. So yeah, it's absolutely mind-blowing. You cannot even think of how to harness that power. But one hypothesis of how we're able to do that over a certain number of years is by sending people and energy out to certain planets and then kind of branching off from there slowly over the next 2,000 years. And you know, the more you branch out, the more that branch can branch out, and the more that branches out, the more that branch can branch out. It's kind of like a exponential graph where you go faster and faster, and the more we are able to branch out because the more of us there are. So if we continue speculating that if, let's say, 1% of intelligent life survives long enough to become a galaxy-colonizing Type 3 civilization, then there should be at least 1,000 civilizations in our galaxy alone, and there's tons of different galaxies. Now, remember, our galaxy looks like this. This is not even all of the galaxies. This is one galaxy among millions. So, like, there's got to be other intelligent life forms out there, so where the heck are there? So the scary thing that's kind of like important to think about right now is the Fermi Paradox. So basically what this paradox is saying is there's something called the Great Filter. And the Great Filter has to do with different like evolutionary bounds where, you know, there's tons of different planets that, you know, have different life that slowly evolve over time and over time. And eventually there's some sort of filter that makes it so no species manage to make it past the filter. Now, the question is, are we beyond that filter or are we before that filter? And that is a terrifying thought to think about. So where in the timeline does it occur? So the first thing that we can think of is maybe we're rare, and one hope we have is we've already passed the Great Filter. The reason we are the only life in the universe is because that filter is behind us and we were able to make it past that point. We've advanced to a point that was so rare to make it to become, you know, humans and to become this type of life form. So we have the chance to become this, you know, Type 2 or Type 3 civilization. We're able to go out and colonize different planets. But why are there no other Type 3 civilizations? So a point of concern is the fact that there's no one else who's reached beyond this Great Filter. So because we've not reached beyond this great filter, what people think is maybe we're the first people to make it beyond that filter, and there's others who are evolutionarily behind us, but kind of like making it this way. But it's a term of billions of years, so it's not like we'd be able to find someone who happened to do this a couple of years ago. They could be hundreds of thousands of years ago, but in terms of the billions of years Earth has happened, it is actually a very low number. So maybe we're first. But that's not the only idea. Maybe, yeah, maybe the filter is ahead of us, and there's been tons of other planets that have actually evolved to the point that we're currently at. And technology is evolving in our current world at a rate in which maybe we're about to hit this great filter where our technology kind of, yeah, or something else happens. I don't know. But the fact that if this great filter is ahead of us, that is something to be greatly concerned about. Because when we hit that point, it doesn't seem like there's, intelligent life elsewhere beyond the point that we're currently at. And the third possibility, which is kind of even more terrifying to think about, is if we are in front of the great filter, maybe the reason no one can make it beyond this society is someone else has already leaped beyond that filter. So there's some superhuman civilization that goes and wipes out civilizations that get close to it because they feel threatened by it. So of the possibilities, the one I think we're hoping for is the fact that we were first in the great filter and we were able to make it beyond it. But yeah, that's a little bit about like just mind-blowing. But wait, why? Like, why are we on this planet? Why are we here? Why are we in the Milky Way? And why do we feel so struck when we see these stars? So, hope you enjoyed watching. There's plenty of talk and conversations to be had about this conversation, and I am by no means a physicist, but I'm a mathematician, a teacher who had a very interesting idea, and I wanted to try and explain this because it's a really interesting thought to think about. If you have more questions, come talk to me, see me, and have a good day.